Welcome to my channel. I am starting by the grace of my creator. How are you all? Using object snap tracking in this lesson, you learn what object snap tracking is and how it can assist you in creating geometry. When you have completed the lesson, you will be able to describe and use object snap tracking to position geometry. Object snap tracking is the most efficient way to locate a point using your existing objects as reference. In the following image, object snap tracking is used to quickly locate the center of the rectangle. Objectives: after completing this lesson, you will be able to describe object snap tracking. Use object snap tracking to position geometry. And about object snap tracking, you often need to place or create geometry at a location relative to other objects in the drawing. While you could create construction geometry for the purpose of aligning the new geometry, with object snap tracking you can accomplish the same result much faster. Object snap tracking defined. Object snap tracking works in combination with object snaps to enable you to temporarily acquire and track up to 7 points. Once you acquire points, object snap tracking provides horizontal, vertical, or polar alignment paths relative to the points that you have acquired. In the following image, the table is being moved to the room center using object snap tracking. To center the table in the room, the midpoint of the wall on the left, 1, and the midpoint of the wall below, 2, have been acquired. Triangular glyphs at the midpoints indicate that the points have been acquired. As the table is positioned near the imaginary intersection, the alignment paths, 3, appear indicating the intersection. The dynamic input interface displays the current position as 0 degrees from the left midpoint and 90 degrees from the lower midpoint. When you need to know the center of a non-circular object such as a rectangle or polygon, use object snap tracking to locate the center point. Object snap tracking guidelines use object snap tracking to reduce the need to create construction geometry. You can use object snap tracking to calculate the center point of non-circular objects. When you use object snap tracking in conjunction with dynamic input, the dynamic input interface displays position information related to the acquired points. Using object snap tracking. To use object snap tracking, you acquire points from geometry in the drawing using running object snaps. As you acquire points on the geometry, a small plus sign appears on the point. This indicates that the point is being used for object snap tracking. In the following image, the midpoint of the left side of the rectangle has been acquired. Notice the plus symbol indicating the acquired point. The midpoint of the bottom of the rectangle is being touched to acquire the point. Touching to acquire a point. To touch a point, hover over the point with your cursor but do not click to select the point. The acquired indicator appears inside the object snap marker when the point has been acquired. Command access object snap tracking menu bar, tools, drafting settings, object snap tab, keyboard shortcut, F11, status bar, object snap tracking, right click, settings, drafting settings dialog box, turn object snap tracking on from the status bar, from the object snap tab in the drafting settings dialog box, or by pressing F11. Object snap must be on and modes must be selected for object snap tracking to work. In the polar tracking tab, you can choose whether to track orthogonally only, simplest method, or to track using all polar angle settings. Alignment paths only appear for horizontal and vertical alignments. Alignment paths appear for all polar angles defined. Press and hold Shift plus Q to temporarily turn object snap tracking on or off. Procedure: using object snap tracking, the following steps outline how to use object snap tracking to acquire points. 1. On the status bar, make sure the OSNAP and OTRACK settings are on. 2. Start any command that prompts you to select a point. To specify a point using object snap tracking, touch the point with the cursor. A small plus appears, indicating that the point has been acquired. 4. Touch another point to acquire its location. 5. If more than 2 points are required, continue to touch points. 6. Move your cursor to a location that would be considered an intersection of the acquired points, based on orthogonal or polar angle settings. The alignment paths appear as your cursor approaches the calculated intersection. 7. Click to select the calculated point. Guidelines for acquiring points with object snap tracking. To acquire a point, touch it with the cursor. To release a point, touch an acquired point with the cursor. You can acquire up to 7 points for object snap tracking. If you attempt to acquire more than 7 points, previous points are automatically released on a first acquired, first released basis. Object snap tracking settings. Key points. Object snap tracking uses running object snaps to acquire points. To use object snap tracking, object snaps must be turned on with at least one object snap selected. Hover over the object snap points but do not select them. Practice exercise, object snap tracking. Practice using object snap tracking orthogonally. 1. Begin a new drawing. 2. Be sure that object snap and object snap tracking are both selected in the status bar. Right-click object snap and be sure that the midpoint selection mode is selected. 3. Draw a rectangle any size. On the Home tab, click Draw Panel Rectangle. Click the first corner, click the opposite corner. 4. Draw a circle, any size, in the center of the rectangle. On the Home tab, click Draw Panel Circle. Hold the mouse over the midpoint of one of the lines in the rectangle until you see a small cross. Then hold the mouse over the midpoint of one of the adjacent lines. Then bring your cursor to the middle of the rectangle. Click at the intersection of the two dotted lines of the horizontal and polar angles. Specify the circle size by clicking a point in the graphics window, or entering a value on the command line. 5. Close all files. Do not save. Exercise, use object snap tracking. In this exercise, you use object snap tracking to create a side view of the part. After completing this lesson, you will be able to use object snap tracking in other drawings. The completed exercise. Completing the exercise. To complete the exercise, follow the steps in this book or in the on-screen exercise. In the on-screen list of chapters and exercises, click Chapter 2, Creating Basic Drawings. Click Exercise, use object snap tracking. 1. Open m_object_tracking.dwg. 2. On the status bar, make sure the following settings are turned on. Polar tracking, object snap tracking, dynamic input. 3. Right-click object snap tracking. Click Settings. 4. In the drafting settings dialog box, select the running object snaps as shown in the following image. Click OK. 5. To draw a rectangle, on the Home tab, click Draw Panel Rectangle. Acquire the lower right corner of the existing shape and move the mouse to the right along the extension path. Enter 40 in the dynamic input field. Press Enter and move the cursor up and to the right. Enter 31.75, 69.85. Press Enter. 6. To repeat the rectangle command, right-click in the graphics window. Click Repeat Rectang. Select the lower right corner of the previous rectangle as the start point. Enter 17.53, 25.4. Press Enter. 7. To draw a line, on the Home tab, click Draw Panel Line. Select the top right corner of the first rectangle. Move the cursor to the right at 0 degrees. Enter 90.55. Press Enter. 8. Move the cursor to acquire a tracking point from the lower right corner of the second rectangle. Track back to the line until the angle shows 90 degrees. Click to select the point. Move the cursor to the left. Enter 46.1. Press Enter. 10. Acquire the point where the arc and angled line meet. 1. Track back to the point where the current line meets the tracking line. 2. Click the intersection of the alignment paths. 11. Acquire the midpoint of the top line of the second rectangle. Track upwards until you get to the intersection of the two tracking lines. Click that point. 12. Select the midpoint of the top line of the second rectangle. Press Enter to complete the line command. 13. Close all files. Do not save. Working with units. This lesson describes how to set up units in a drawing. When you create drawings, one of the first things you must do is define the current working units. The units settings determine how you enter distances as well as how the values are returned to you. The following illustration shows how the software presents the current units through the dynamic input interface. Objectives. After completing this lesson, you will be able to describe units and how they affect your drawing. Use the units command to set drawing units. About units. Units represent the baseline of all the geometry that you create in your drawing. It is up to you to determine what unit of measurement will be used in your drawing. When you begin a blank drawing, the default units are based in the decimal system. Because the software is not capable of distinguishing inches from millimeters, it assumes that a value of 1 is equal to either 1 inch or 1 millimeter. Setting the appropriate units determines the format in which the software presents values to you via the command line, status bar, polar tracking, and dynamic input interface. While the software is not a true units-based system, meaning it doesn't understand the difference between 1 inch and 1 millimeter, there are some assumptions that can affect other settings such as imperial architectural units, for example 1-6, and alternate dimension display. Unit guidelines. The following are some guidelines you should refer to regarding units. The software is set by default to decimal units. A unit of 1 can be equal to 1 inch or 1 millimeter. If you need to input imperial architectural units for distances, you must select the architectural type drawing units. The software will not understand the architectural units format 1-6 if the units are set to decimal. When you are using architectural units, type the foot mark, but it is not necessary to type inches as the software will assume inches if no symbol is typed. Example 16-2 can be simply typed, 16 feet 2 inches. When using architectural units, you may type 16-2 or the equivalent in inches, 194. If you work primarily with metric units, then you should use the default decimal unit setting. AutoCAD is accurate 14 decimal places, 1.0000000000000000. What you see for units precision will be rounded up to the nearest decimal place that you have determined in the units dialog box. Simply picking points in the drawing window will not guarantee that you have specified the precise length or angle unless you use the drawing aids determined in the drafting settings. Units example. The following image illustrates the assumptions made regarding units. In this image, a single line was drawn at a length of 18 units. When dimensioned with both a metric and imperial dimension style, the dimensions report different lengths. This occurs because the default dimension styles have preset conversion factors when you display alternate units. While you could change these conversion factors to represent any conversion imaginable, by default the software assumes a conversion using inches or millimeters as the base unit. Setting units. You use the units command to set up the units for the drawing. You can change the drawing units at any time, but it is recommended that you do so at the beginning of each drawing you create. When you use drawing templates or the new drawing wizard, the units for the drawing are set accordingly. In the following image, the drawing units have been set to accept surveyor units for angle input. Command access units. Command line, units application menu, drawing utilities units. Drawing units dialog box. When you start the units command, the drawing units dialog box is displayed. You set the unit types for length, angle, and insertion scale. You can set the precision for both length and angle units, and you can also set the angle direction. The precision options are displayed in the selected unit format. To set your drawing units, select the appropriate unit in the length and angle lists and then set the unit's precision with the precision lists for length and angle. Current unit setting. The current unit setting affects the manner in which values are presented to you as well as the format in which you can enter distances and angles. Regardless of the unit setting you choose, you can always enter values in decimal format. Warning: the lighting area shown in the units dialog box is not available in AutoCAD LT. Procedure: setting drawing units. The following steps give an overview of setting drawing units. 1. On the command line, enter units and press enter. 2. In the drawing units dialog box, select the appropriate length and angle unit types. If necessary, you can also adjust the precision options for both length and angle. 3. Click OK. 4. You can now enter values using the format of the selected unit for length and angle. When the software presents values to you via the interface, they are in the selected unit format. Guidelines for setting units. While it is possible to set the drawing units at any time, it is recommended that you do this when you start a new drawing. Regardless of the current unit setting, you can always enter units in decimal format. To input values in a format other than decimal, you must set the appropriate unit type. Practice exercise. Setting units. In this practice exercise, you create a new blank drawing, set the drawing units to architectural, and draw a rectangle 54 feet 6 inches x 34 feet 2 inches. Then you zoom all to see your work. 1. Begin a new drawing. In the Select Template dialog box, select the academic drawing template. 2. To set the architectural drawing units, on the command line, enter units and press enter. In the drawing units dialog box, under length, select architectural in the type list. Click OK to exit. 3. To draw the 54 feet 6 inches x 34 feet 2 inches rectangle, on the Home tab, click Draw Panel Rectangle. Specify the first corner point. To specify the opposite corner, enter at 54 6 34 2. Note, you do not have to enter inches. 4. To zoom your drawing, enter Z and press enter. Enter A and press enter. Exercise, use architectural units. In this exercise, you set the drawing to use architectural units. Then, using the dynamic input interface, you sketch the outline of a simple floor plan. The completed exercise. Completing the exercise. To complete the exercise, follow the steps in this book or in the on-screen exercise. In the on-screen list of chapters and exercises, click Chapter 2, Creating Basic Drawings. Click Exercise, use architectural units. 1. Open I_architectural units.dwg. 2. To set the unit type, click the Application button. Drawing Utilities Units. In the type list under Length, select Architectural. In the Precision list, select 0 feet -0 and 1/8 inches. In the Precision list under Angle, select 0.0. Click OK. 3. To draw a line, on the Home tab, click Draw Panel Line. Enter 1010. Press Enter. Move the cursor to the right. Enter 6-8. Press Tab. Enter 0. Press Tab. Click anywhere in the drawing. For the next point, move the cursor down and to the right. Enter 2 feet 4.25 inches. Press Tab. Enter 45. Press Tab again. Click anywhere in the drawing to accept the point. 5. For the next point, enter 4. Press Tab. Enter 0. Press Tab. Move the cursor to the right. Click anywhere in the drawing to accept the point. 6. For the next point, move the cursor up and to the right. Enter 2 feet 4 -1/4 inches. Press Tab. Enter 45. Press Tab. Click anywhere in the drawing to accept the point. 7. For the next point, move the cursor to the right. Enter 45-8. Press Tab. Enter 0. Press Tab. Click anywhere in the drawing. 8. For the next point, move the cursor up. Enter 42-8. Press Tab. Enter 90. Press Tab. Click anywhere in the drawing. 9. For the next point, move the cursor to the left. Enter 15-3. Press Tab. Enter 180. Press Tab. Click anywhere in the drawing. 10. For the next point, move the cursor down. Enter 6-2. Press Tab. Enter 90. Press Tab. Click anywhere in the drawing. For the next point, move the cursor to the left. Enter 44-5. Press Tab. Enter 180. Press Tab. Click anywhere in the drawing. 12. Right-click and click Close, or select the endpoint of the line where you started. 13. Close all files. Do not save. If any need, contact me by Gmail md.assad7157@gmail.com. Thanks for watching. Subscribe my channel and press the bell icon to get next video.